As we always do, let me know which country are you from? And yeah, it'll be good to know the global participation. So put that down in the chat window for everyone to see. And I'm going to call this out. Welcome, everyone. We have people from Mexico. We have people from UK, US. Of course, we have people from India and UK again, Germany. India is kind of 9 o'clock here. The Greenwich Mean Time is about what, 3 o'clock? Yeah, GMT. And of course, the US time is about 10:30. Germany, we have someone from Israel as well, high up there. What else? Colombia, welcome. Other countries? Any other country? Okay, that's pretty much it, is it? Okay, let's just wait for Romania. Okay, great. Great to have all of you here today. I'm going to just do the checking. It's selected as Rode Micro Podcaster. We are all good. And yeah, the screen is being shared. Friends, I hope I am not changing your view. I hope you can customize your view. You can see the screen and you can see the speaker on the side. I hope I'm not changing that. I mean, if by mistake I've changed that, please just change the settings, the display settings as per what you feel best. For some reason, my screen up here is different. Hmm. Okay, friends, looks like we're all good to go. And once again, for people who have just joined, is the audio good? Is the video good? And you can see the screen. And I'm all ready to start today's content. In the chat window, if you can please confirm all well. Okay, perfect. All right, friends, welcome. Welcome to another webinar from SQL Maestros. My name is Amit Bansal, and I'm going to be your host for the next 1 hour, probably 45 minutes, because now our webinars are going to be very short, crisp, and precise. Specific demonstrations, very to the point topics, so that your takeaways are very crystal clear. After the webinar is over, you will have a very clear understanding of, okay, why did you spend time with me? What demonstrations have you seen? And what have you learned? How can you apply those learnings back to your SQL Server production environment? So it's important that we don't do too many things, but whatever little we do that really well. That's the whole idea. Okay, my background, I have been working with SQL Server for a couple of years now. I started in 1997, and then in 1997, I had like those initial days with SQL Server 6.5, and then I quickly moved up to 7.0. I did a lot of application programming with SQL Server at the backend, and I did a lot of programming with Visual Basic. Back in the days, it was Visual Basic 6. And then gradually, it wasn't planned, but I moved towards SQL Server because of my liking with the database and the tuning stuff that we did, and it was nice. I just loved the entire data part of things. So yeah, since then I haven't looked back. I've worked with all versions of SQL Server from that point onwards, and I have been focusing a lot on performance tuning and optimization, troubleshooting slowness, and all that stuff. I'm also a Microsoft certified master of SQL Server. Back in the days, I used to be an MVP and used to be part of the community with conferences, etc. But all that is now history. All I do is I consult with customers who are running big SQL servers, and I work with their team members. I do training, I do performance tuning stuff with them. And whatever I learn, I bring those back into my classes, into my webinars, and into those short tutorials, videos that I put up on YouTube. That's about me. Okay, friends, what do we have today's content? Today's content is about the physical join types inside SQL Server. Now, joining, whenever we talk about joining, we think about joining two tables, and that's exactly what we are going to see. A join inside SQL Server always happens between two tables. And when we say two tables, we can interchangeably use the term two inputs. Remember, the SQL Server Optimizer, or generally in the relational world, you can always join only two inputs. You can't join three inputs at one go. You will join input A with input B, and the output of that is going to be joined with input C, so on and so forth. And that's how you join multiple tables. So it's a step by step operation that happens. When you are joining two tables or two inputs, you are specifying what kind of joins you want. Like, for example, if you look at these examples that I'm going to show you today here, you have a inner join, you have a left join, and then so many different types of joins like inner, left join, right join, full outer join, equi join, non-equi join, semi join, anti-semi joins, so on and so forth. There are just so many of them. These are all logical conditions, join conditions. These are all logical join types. It's important that we understand what is really meant by logical and physical. Logical join types here, all of these things that we called out, like inner join and the left join and the right join, all these are logical join types. They are basically specifying how do you really want, what logic, what pseudocode do you really want to apply to two inputs? What's your join condition between two inputs? So that's a logical instruction as to what you really want to do. So these logical join types are telling SQL Server, when you punch down your SQL queries, they are telling SQL Server what kind of join do you want. And then there's so many of them. But it is up to SQL Server how that join is going to be performed. Now we are coming into the world of how to do that job. So with your SQL query, when you specify the join type, you're telling SQL Server what you want. Now the query goes to the optimizer, and the relational engine is working on the optimizer's instruction how to perform that join operation. That is what is meant by physical join type. It's really like now physically the work is being done, which is two inputs are being joined. And there are three different techniques, three different ways how that physical join can happen. First one is nested loop join, the second one is merge join, and the third one is hash join, which means there are only three ways in this relational world of SQL Server. There are only three physical techniques as to how two inputs can be joined. We're talking about physical work now, like take one row from input A, compare it with one row from input B, then come to a conclusion that yes, is it a match or is it not a match, so on. So that is the physical work that is happening. And there are only three ways how this can be done: nested loop, merge, and hash, which means all the logical join types that we talked about has to translate to any of these three physical join types. All right. I hope that is pretty clear to all of you. Now comes the important part. Why does SQL Server really have these three different join types? How does it decide which one to use? Can you tell SQL Server which one to use? Of course, I'm sure you know that, oh, the optimizer generally decides on its own. And when you look at the execution plan, and I'm sure you have looked into the execution plan so many times, you will probably come across all of these like nested loop, merge, and hash. So Let's demystify all of these things now, right? That's the whole crux of this content of this webinar. Okay, first one, nested loop join. If you look at this query, in fact, all the queries are joining only two inputs, but they're going to take different join, physical join types. First one, nested loop. I'm going to select this query and I am going to run this. Oops, very good. First part of the demo comes up with an error. So the query gets executed, jump over to the execution plan, and you can see a nested loop join here. So what you can see here is the logical condition, left outer join, and how was the job physically done? That is nested loop. If you take the cursor over nested loop here, you can see the physical operation and the logical operation. This is what I was really explaining earlier. So your logical operation was you told SQL Server, I want a left outer join. That is how you specify in your select query here. But then how was the job actually done? It was done using the nested loop logic. Now, what is all that? We're going to come to that in a moment. Let's move on to the next one, merge join. Again, we're just joining two tables, but this time, of course, few things are different. So SQL Server decides to use a merge join logic now. You can see the merge join here clearly and the logical operation as inner join. And again, just to prove the point, take the cursor over merge join, and in the tooltip, you can see inner join as logical operation and merge join as physical operation. Okay, perfect. Let's move on to the third one, hash join. For me to show you hash join, I'm going to move to the data warehouse because it just more easier to kind of um, reproduce hash join with fact tables and dimension tables, etc. So let's take this one now. Execute again. Two inputs. The idea with all the three queries is exactly the same. Two inputs and the joining keys. That's pretty much it. Jump over to the execution plan, and now you can see a hash match, which is your physical operation, and inner join is the logical operation. Take the cursor over here, and you can see both of them. Okay, all good. Now, let's start with the first one. What's the difference between all three of them? Nested loop. So for that, friends, I have a lovely PPT for you. Okay, and this PPT has some animation. This is from our masterclass content, some bit of that. So I can really just take which one should I take? Yeah, I will take this one. Okay, nested loop. So what I'm going to do now is explain you the differences between all three of them, and try to act like an optimizer, like I am the optimizer. What do I really look for before I decide which physical join to choose? Of course, there are certain conditions, criteria, caveats. If some of those are met, I will use a specific join type. In other cases, I will use some other join types. I'm going to talk about those things. It's like thinking like the optimizer here. Nested loop join. So what you can see is two tables here, right? Table A and table B. So you have the outer table and you have the inner table. So the moment you send your query to the optimizer will first decide which table is going to be the outer table and which is going to be the inner table. Generally speaking, the smaller table becomes the outer table and the larger of the two becomes the inner table. Nested loop logic is very, very straightforward. It's like take one row from the outer table and compare it with each row in the inner table. And after that job is done, take the second row from the outer table and compare it with each row in the inner table. And whatever matching rows you're getting, you take them on one side and reject the others. Then take the third row, compare it with all the rows from the inner table. Likewise, it does the job with all the rows are being compared from the outer table with the inner table. And it's important that the outer table is the smaller table because outer table really defines the logic and the whole operation with the number of rows in that outer table. That is how nested loop join works. So the cost of nested loop join really is table A multiplied by table B. Generally speaking, the cost factor, table A multiplied by table B. Nested loop does not have any criteria. It does not have any condition. The the pseudocode, the logic of nested loop is very straightforward. The optimizer says, you know what, I can apply nested loop to any two inputs. Just give me two inputs. I can always use nested loop freely. Why? Because I can always compare each row from the outer table with each row from the inner table, right? So each row from the outer table is compared to each row from the inner table. Matching rows are selected. Usually, not always, SQL Server selects the smallest input as the outer table. As I said, generally, the smaller table goes as the outer table. Okay. No extra memory grant is required and there is no criteria. It's important to call out whenever you're talking about SQL Server or the databases in general, each operation, when we work as DBAs and developers, we always think in terms of resources because performance is always there back of our mind. Each operation, is it resource intensive? And when you say resource intensive, what resources are you really talking about? We're talking about the CPU, we are talking about the memory and IO. And of course, the fourth one, tempdb. I consider these four the foursome. I call them as the foursome: CPU, memory, IO, and tempdb as the four most critical resources in SQL Server. So each operation you should always think in terms of, is it resource intensive, is it not? So uh, any specific operator inside the execution plan, is it consuming more CPU cycles? Does it require extra memory grant? Is it spilling down temporary data into tempdb? And if that happens, even IO is being consumed. You got to look into all of those things. The good thing about nested loop is that no extra memory grant is required. It's not very resource intensive. So yeah, good. But it can be CPU consumption will always be there because it's a lot of work, right? The comparison between the two tables with each row there. So that's some work. Okay. Graphically, just let's look at this quickly. You have table A and then you have table B. You will notice, look at the data there. It's not necessarily that the data is ordered. That's very important. I can see table A, the data is ordered 1, 4, 5, 7. But if you look at table B, the data is not ordered. You have 2, 4, 6, 7, 9, and then 1 comes right at the end. So it's not, as I said in the previous slide, no criteria. It's not important that the inputs need to be sorted. Two inputs are given to the optimizer. Let's go and join them. Select star from table A, inner join table B, and the condition table A dot ID is equal to table B dot ID. What happens? The first row from table A is compared with the first row in table B. Is it a match? No, it's not a match. Then it goes and is compared to the next row. Is it a match? No, it's not. Then the third comparison, 1 to 6, no match. It goes and compares itself with the fourth row, no match. Then the fifth row, no match. And then the last one, yes, there is a match. When there is a match, this is outputted, right? So that goes into this temporary output table, which is also in memory and is produced. And likewise, you will have the second row compared with all the rows in table B. And then 4 is the matching row, which goes as the output. Then you have 7. And yeah, that's how it goes. 5, there is no match. 7 has a match. So the output is 1, 4, and 7. Question is coming in. Good. Yes, friends, you can punch in your questions in the chat window to everyone. Please do that so that all participants can read your question. It's always good about that. So Eric has a question, says, okay, it doesn't use the index to do a seek, it does a scan. So Eric, let's not bother about scanning and seeking here because at least in nested loops, there's no such criteria. If you have an index, well and good. Even if you don't have, it's anyway going to pick up all the rows. That's the job here. So index is not a criteria, not a constraint, not a preference as far as nested loop is concerned. But yeah, for the other physical join types, index will become a point of discussion. Good question there. Okay, friends, let's move on. I hope this was pretty clear. In fact, nested loop is very straightforward to understand. Merge join. Okay, let's go to merge join. So before we come to the slide, I will first show you the demonstration here. Merge join. If you want to watch the remainder part of the webinar and all the remaining demos, you can subscribe to the webinar on sqlmaestros.com and get lifetime access to the recorded webinar. All you have to do is just go to sqlmaestros.com, click on the recorded webinar section and get access to all the webinar recordings. There are many of them. Some of these webinars are free and some of them are very nominally priced. So the ones that you're interested in, you can subscribe to them and get lifetime access. Now, because there are so many webinars, subscribing to each webinar might be a bit cumbersome. So we have another option, which is SQL Maestros membership. So the first link on SQL Maestros says join. If you click on that, it will bring you to SQL Maestros membership. Things are very simple. There are two membership levels. The first level is free, where you get access to all the free webinars and all our tutorials and demos, more than 200, 300 demos and tutorials. All you have to do is just become a free member. You're paying nothing and you get access to all of them. So you don't have to go and subscribe to each webinar individually. Just become a free member and then explore the free video lobby. So if you go to the video lobby here, there is something called as free content where you get access to all of that. But then all of us are interested in advanced content, isn't it? And that is where premium membership comes into play. So the webinars that are paid, and there are many advanced tutorials and demos. If you want access to all of them, you can become a premium member and pay a nominal price, which is annual membership. Once you do that, you can explore the premium video lobby. If you go to the premium video lobby from here, or just go to the video lobby and click on premium content, you can see all the paid webinars and all the advanced tutorials and demos and get access to all of them with your annual membership. Anyway, choice is yours. There's a lot of content on sqlmaestros.com, and you can also explore the YouTube membership level as well. So you have free content on YouTube channel, and you can also join and become a member of SQL Maestros on YouTube, where you can pay a monthly fee, get access to all the paid webinars and advanced content. So in summary, you can go to sqlmaestros.com and become a member, or you can become a member on YouTube also. Becoming a member on sqlmaestros.com turns out to be a little cost effective with the annual membership in comparison to YouTube monthly membership. But anyway, choice is yours, whichever platform you wish to use. Happy SQL.